Hi everyone, my name is Cameron Ramirez, and today I'm presenting my research on environmental exposure to perfluorooctanoic acid, or PFOA, and its association with embryo quality in women undergoing IVF. This topic is really important because it connects environmental health with reproductive outcomes, particularly in populations already facing fertility challenges. So why does this matter? Infertility is a growing public health issue that affects millions of women worldwide. For many individuals and couples, in vitro fertilization, or IVF, becomes a necessary option for them to achieve pregnancy. One of the strongest predictors of IVF success is embryo quality, which reflects how well an embryo develops during the earliest stages. While medical and hormonal factors influence embryo quality, are really well understood, environmental exposures have received much less attention. This is concerning because many environmental chemicals are persistent and can interfere with biological processes that are critical for reproduction. Understanding how these exposures affect embryo development is really important, not only for individual patients but also for public health and prevention strategies. PFOA is a synthetic chemical that belongs to a group called pair and polyfluoroalkyl substances, or PFAS. These chemicals are often referred to as forever chemicals because they resist degradation and can remain in the environment and the human body for many years. Exposure to PFOA is widespread and largely involuntary. Common sources include contaminated drinking water, certain foods, and consumer products. Studies have shown that PFOA is detectable in the blood of most women of reproductive age. Importantly, research suggests that PFOA can reach the ovarian follicle, meaning it can directly interact with oocytes and early stage embryos during critical periods of development. The key study I used for the research was conducted by Sue and colleagues in 2025. This cohort study examined PFOA concentrations in follicular fluid among women undergoing IVF. Follicular fluid is especially important because it surrounds the developing oocyte and directly influences embryo development. The researchers found that higher levels of PFOA in a follicular fluid were significantly associated with poorer embryo quality. Embryos from women with higher PFOA exposure showed abnormal morphology and reduced developmental potential. Notably, these effects were observed at exposure levels commonly found in the general population. The study also used metabolomic analysis, which revealed disruptions in energy metabolism and increased oxidative stress. These biological changes provide a plausible explanation for how PFOA may impair embryo development at the cellular level. Findings from other studies support the results because they reported that higher plasma PFAS levels in IVF patients were associated with fewer retrieved oocytes and lower quality embryos. This suggests that both localized and systemic exposure may affect reproductive outcomes. Population-based studies further strengthen this association. It was found that higher PFAS exposure was linked to a longer time to pregnancy and increased fertility risk. Additionally, mechanistic evidence indicates that PFAS can disrupt hormone regulation, ovarian function, and oxidative balance. Together, these studies suggest a consistent pattern across clinical, population, and mechanistic research. In conclusion, current evidence suggests that environmental exposure to PFOA may negatively affect embryo quality and reproductive outcomes in women undergoing IVF. Even low-level chronic exposure appears capable of disrupting early embryo development. These findings have important public health implications, particularly as the use of assisted reproductive technologies continue to increase. Reducing PFAS exposure through environmental regulation and prevention efforts may help protect reproductive health. This research highlights the need to consider environmental factors when alongside clinical care when addressing fertility challenges.